All right, welcome students again. So this is the next installment of Booklet Solutions, and in this, primarily the questions from the previous homework are being discussed. Now these questions are from FBS Foundation Based Objective and Get Equipped to Advanced section. Now, before I start the discussion, a very important point which I would want to highlight. While doing these questions, a lot of you would have struggled with the calculations aspect, like the data given in the questions, like as you can see in the first question in front of you, the data is in 4 decimal places. Like, and doing it, once you know the concept of how to do a question, it becomes really annoying sometimes that you are spending more time in doing the calculation rather than thinking about the actual part of the solution or how we get the answer. So thank you for the patience, I would say, of bearing with these questions. However, please be clear on this point that when it comes to J examination, when it comes to tests here at PACE as well, the questions are designed in a manner that the data is easy to calculate and work with. ठीक है, हम लोग आपका न्यूमेरिकल कैलकुलेशन स्किल नहीं चेक करते हैं when we are going to take tests. We are actually going to test your conceptual knowledge, how well you are able to understand and comprehend the question and come up to a solution. ठीक है, numerical calculations will be a part of it, but it will be a small part. Like in this homework, like you can consider this as a very subjective question based homework. इसमें बहुत ज़्यादा calculations and बहुत ही गंदे calculations थे with a lot of questions. So those who have posted the solutions in the group, like especially the Andheri group, which I saw many students coming up with doubts and their fellow colleagues coming up with solutions. Some even came up with solutions. I was just checking with really brilliant solutions. Even I would have not thought of that as a shorter or a faster way. So kudos to you guys. And in other groups, in Dadar and Borivali and Podar, I have not seen much interaction coming from the students. Maybe I will talk about it in my live session, and then the momentum will start rolling in. All right, so let's begin with this doubt discussion session on the video solutions. Now, first question is 23rd question, which talks about a compound. Now, well, there's this flaw in the question. The question should have mentioned that the compound is actually hydrocarbon. Okay, so that you can actually write an equation. If it was something which contained oxygen as well, then it could have been a problem, a different statement altogether. So the question should have mentioned that it's a hydrocarbon. So based on that, you know how to write a balanced equation for it. This is something that we have practiced a lot in our classes. And you have been given these mass data of the different reactants and products. Now, how do we establish relationship between them? Moles upon coefficient is equal to moles upon coefficient for reactants and products. And based on that, when we look at the data of CO2 and H2O, we can actually get a relationship between X and Y quite conveniently from there. Well, convenient is an overstatement here. Calculation करनी पड़ रही है, ठीक है? All right, 27th question in FBS. Now, this is something जिसका मैंने reaction आप लोगों को साथ में mention कर दिया था with the question itself, that यहाँ पर मिक्सचर है NaHCO3 का एंड Na2CO3 का, ठीक है, एंड टिपिकली इसमें दिया नहीं है, बट जब दिया नहीं होता है मिक्सचर का कॉम्पोजिशन, तो वो कॉम्पोजिशन बाय मास ही होता है, ठीक है. सो यहाँ पर योर स्टार्टिंग स्टेप, this becomes your starting point, that let the mass of NaHCO3 is m. Now this is the reaction that I had mentioned in the group itself, that NaHCO3 decomposes into Na2CO3, H2 and CO2, and these are the species because of which the loss in mass occurs. For Na2CO3, I had mentioned that Na2CO3 does not decompose so easily. Okay, it decomposes, but it decomposes at really high temperatures, 800 degrees centigrade and plus. So इस क्वेश्चन में मैंने स्पेसिफाई कर दिया था that Na2CO3 का decomposition आपको नहीं लेना है. The only decomposition that you have to take is of NaHCO3, and as a result of which the loss in mass is because of the weight of H2 and CO2. So if you have taken the mass of NaHCO3 as m, and these are its moles, we can do the unitary method analysis, and based on which calculate the moles of H2 and CO2, and then report their mass, which is given in the question as the loss in mass, which will help us to calculate back the value of m. Okay, and then hence you can compute the percentage composition. All right, 28th question, again full of calculations, especially this table method, empirical formula calculation. I really don't like it. Like trust me, it's too much of effort for a question which has a very less chance of being asked in the examination. So anyways, continuing the saga of calculations in this homework, we come across the table method because there are so many elements, and based on which you follow the step by step column calculation, and you will end up with a relative number of atoms. So this is what you end up is the number of atoms, and then you are being asked percentage of carbon atoms. So percentage of carbon atoms is actually carbon atoms upon the total number of atoms that were there. All right, then 29th question. Yeah, it's a simple straightforward questions. The temperature pressure conditions are not useful for mole concept calculation. They are just as an additional information, kind of elaborating a question. And थोड़े बहुत नाम दे दिए compound के, acetic acid, oxygen, acetaldehyde. Well, as of now, we do not expect that you will be knowing all these compounds upfront, and that's why in the questions also these compounds have been given their formulas alongside with their names. So I hope that is not a trouble for you guys to kind of match and move on with the question. Whereas when you come to the problem solving approach, this is as simple as it gets when it comes to a limiting reagent based concept question. Okay? It's straightforward. In the last part, once you are done with the calculation and you computed the mass of CH3COH, this is actually the expected mass. Now what you need to understand is that not this mass was actually observed, some other mass was observed in the C part of the question, and that leads to the formula of percentage yield. That actual mass of the product upon the expected mass will give you the yield. All right. Then 30th question, like again straightforward, not worth discussing. We have done such questions multiple times in our class. Okay? Since we have not done the exact same question, I have still gone ahead and done the calculation for you guys. So if किसी का आंसर मैच नहीं करा है, please identify the careless mistake that you would have made. All right, 31st question. Well, straightforward question again. There is CH4 and C2H4, and दोनों का combustion का reaction हमें लिखना आता है. दोनों का total mass x दिया है, तो हमने CH4 का x मान लिया है, and C2H4 का 5 minus x हो जाएगा. Again, हमने इनके moles calculate कर लिए individually, and correspondingly based on their balanced equations, we are able to calculate how many moles of CO2 are going to form. ठीक है? Once you are able to get that, calculate the total moles, total mass of CO2, and the data for that is given as 14.5 grams. So based on that, you will get the value of x. Straightforward again. Then 34th question. 34th question again. The reaction of combustion not combustion, actually heating of calcium carbonate. Okay, my bad. Sorry, that was 35th question. 34th was actually about AgCl. Reacting with NO3 reacting with NaCl and forming AgCl. Again, straightforward question. आपको reactant का mass दिया हुआ है, तो आपने उससे moles निकाल लिए, moles से आपने stoichiometric ratio निकाला and identify करा limiting reagent comes out to be AgNO3. ठीक है? Again, not a set of pleasant calculations. So based on that, you calculate the moles of AgCl and then the mass. Okay. Then 35th question. Yeah, this is actually the 35th question. Now in that 35th question, the mass of calcium carbonate and magnesium carbonate both show the same reaction upon heating. The residue is their oxides, and CO2 gas is liberated. So if you start with just assuming that mass of calcium carbonate is x, then the mass of magnesium carbonate is 1.84 minus x, and then you do the mole analysis, right? X is the mass of calcium carbonate, 100 is its molecular weight, and 84 is the molecular weight of MgCO3. Based on that, you compute the moles of the oxides and then multiply by their respective molecular weight to get their mass, and this is given to as 0.96. You will get the value of x. Now 36 and 37 were discussed in class. 38th, yeah, one sorry question with so much bad calculations. But it's a difficult question, and over and above that difficulty level, the calculations were horrendous. So here we go. It's a parallel reaction. As you can see, the same reactant undergoes two reactions. Right? There is this first reaction जिसका analysis मैंने यहाँ पे करके दिखाया है. because आपको O2 का amount दिया है and that is something in milliliters in at NTP, and based on that, because ये milliliters में तो पहले तो liter में convert करा and then उससे moles निकाले. So these are the moles of O2, and based on the coefficients, we can compute the moles of KClO3 and KCl. ठीक है. Not a pleasant calculation, but when you compute the moles and you multiply by their molecular weights, you will get the mass of KClO3 consumed. Okay, this is the mass of KClO3 consumed, and you will get the mass of KCl produced. Right, moles को आपने again KCl के molecular weight से multiply कर दिया. So once you get that, then you can move on to the second reaction. Now, second reaction is actually something where because we now know that 0.535 grams of KClO3 reacted in the first reaction, we can then compute that how much of KClO3 is being used in the second reaction. Now, based on that calculation, we can start analyzing the second reaction also. The coefficients are also given the balanced form, and mass of KClO3 is given. So based on that, we calculate the moles of KClO3 and then apply again unitary method to compute the moles and then corresponding mass of KClO4, and similarly moles of KCl and then corresponding mass of KCl. Okay. As I said, the calculations are really bad. This is not something which you will see in tests. Like, it is just too much of laborious work. So coming to this, you did the calculation, you got the mass, and then you are being asked the percentage of KClO4 in the residue, right? So that is also something that you have to decipher. That in the end, as you can see the reactions, these are solid species. Now at the end of the reaction, let me take the first reaction as well. These are solid species while O2 is gas. Okay, so O2 will be liberated. Okay, KClO3 as a reactant is consumed. Okay, it is gone, and what is left is KCl in the first reaction. Similarly, in the second reaction, KClO3 as a reactant is consumed, whereas these two actually, KClO4 and KCl are left as residue. So what is residue? Residue is actually mass of KClO4 that was formed in the second reaction and the mass of KCl which was formed in both the reactions. So that is what is meant by residue. So percentage of KClO4 in the residue will be mass of KClO4 upon the mass of entire residue, and we have computed all those values above which we are using and going to calculate the percentage composition. Okay. Really tiring calculations. Like, I'm running out of synonyms now to talk about how bad the calculations were. Now, then comes the 40th question. So 40th question, yeah, it's a good question. It's not actually bad in terms of calculations. It's a question which is actually a kind of question that you can expect in tests. It's a sort of series reaction, but the thing is that आपको English comprehend करना पड़ेगा. How it is happening. So zinc is going to react with acid. ठीक है, ये पहला reaction जो question में दिया हुआ है. Zinc is going to react with acid, and as a result H2 is going to be produced. ठीक है. Then it says that जो H2 produce हो रहा है उसको ऑक्सीजन के साथ react करना है, and वो ऑक्सीजन आएगा कहाँ से? ठीक है, वो ऑक्सीजन आएगा इस पहले reaction से, KClO3 के decomposition से. And data KClO3 का दिया है, तो हमने analysis पहले KClO3 के reaction के साथ में start किया, that KClO3 decomposes to give you KCl and O2. And based on the mass you get the moles, and based on the mole analysis you get the moles of O2. Now looking at this reaction where H2 and O2 react, again the 3/40 moles of O2 require how much of H2? We get that value, and that is something which we use in this reaction where we know that 3/20 moles of H2 are being produced. So how much zinc is required? It comes out to be the same moles, and then based on that we compute the mass of zinc. Okay. Again, quantity of zinc लिखा है, quantity, mass, moles कुछ भी हो सकता है. तो subjective questions में sometimes they have not mentioned कि mass पूछा है, moles पूछा है. That is something which is the flaw in the question itself. ठीक है. Any good question should always specify that आप mass पूछ रहे हो कि moles पूछ रहे हो. Objective में फिर भी क्या होता है, options आपके सामने आ जाते हैं, तो you should or you are able to actually see that what is the quantity that is being asked. So यहाँ पर only when you look back into the answer then you realize कि अच्छा mass पूछा है, so then you compute the mass. Otherwise हो सकता है कोई moles पे भी छोड़ दे. All right, then 41st question. Straightforward. I'm not even going to discuss. It's so simple. Then 42nd has been done in class again. Parallel reaction का case था. दो methods से मैंने समझाया था. तो अगर आपको नहीं फिर भी स्ट्राइक हुआ कैसे करना है, तो दैट इज समथिंग रियली इट्स अ गुड थिंग। अगर नहीं भी स्ट्राइक हुआ है बट यू स्टिल रियलाइज इट दैट मुझसे नहीं हुआ है, तो डेफिनेटली गो थ्रू दैट सोल्यूशन दैट वी डिड इन द क्लास एंड ट्राई टू रीडू द क्वेश्चन बाय योरसेल्फ। ठीक है, देन प्लीज समझना फिर आप क्या हो रहा है, क्लास के बाद में रिविजन नहीं कर पा रहे हो, खुद से क्वेश्चन नहीं सॉल्व कर पा रहे हो, तो आप क्या सीख रहे हो, कैसे वाला पार्ट नहीं सीख रहे हो। दिस इज समथिंग एग्जैक्टली व्हाट आई टोल्ड इन द क्लास, यू आर हियर टू लर्न हाउ, नॉट द व्हाट एस्पेक्ट। Then 59th question, straightforward reaction मैंने mention कर दिया था। H2SO4 का role is here, it's like an agent that facilitates this reactions. It really does not participate in the reaction. It results in dehydrating of H2O, H2C2O4. Now इसमें मैंने भी एक careless mistake कर दी थी कि मैंने H2O को gas count कर लिया था and फिर मेरा आंसर मैच नहीं करा था end में। Then I realized that at the NTP conditions that are given, H2O will be liquid. ठीक है, that is something to be deciphered from the question itself. अदरवाइज कई बार केयरलेस मिस्टेक हो जाती है, मैं भी कर देता हूँ। तो H2O को आप लिक्विड मान के इग्नोर करना। द गैसेस आर CO एंड CO2 ओनली, जिनके मोल्स आपने ऐड करे एंड उससे उनका वॉल्यूम आपको मिल जाएगा। All right, coming to the get equipped section, question 7 again done in class। पैरेलल रिएक्शंस का यही डेटा, यही क्वेश्चन मैंने क्लास में कराया था, वापस से दोनों मेथड से कराया था, ध्यान से ऑब्जर्व करना। Then 18th question, very easy, straightforward, like you have been given mass of KClO4 and as a result, in fact you have been given the mass of sample of KClO4, not the mass of KClO4। तो आप O2 के अमाउंट से KClO4 का अमाउंट निकालोगे बेस्ड ऑन द यूनिटरी मेथड एनालिसिस, मोल एनालिसिस। अगेन आई हैव इंसिस्टेड ऑन मोल एनालिसिस। Some students still do the other analysis, that's okay, that's fine by me, but for those who are new to this approach, adopt mole analysis, because आप नोटिस करोगे आज से 6 महीने बाद में यही एनालिसिस हम लोग ज़्यादा करने वाले हैं। मास वास वगैरह सब भूल जाओगे, मास स्टार्टिंग में सिखाया जाता है। So directly jump to mole analysis. Now based on that you calculate the mass of KClO3 and because percentage purity पूछा है तो आपका फॉर्मूला स्ट्रेट फॉरवर्ड है, mass of KClO4 upon mass of sample into 100%. Then 21st question, yeah, looks like a lengthy question but simple straightforward question। already balanced equation दिया हुआ है, coefficient 1 1 दिए हुए हैं आपको, and अगर अपन यहाँ से start करें, let the mass of toluene C6H5CH3 be x grams, तो आपको उसके moles मिल जाएंगे, and then by unitary method you can calculate the moles of the compound which is being produced, right, potassium benzoate। now अगेन एज आई सेड दैट आपसे एक्सपेक्टेड नहीं है कि आपको ये नाम कंपाउंड्स के पहले से पता होंगे, तो आप लेकिन क्वेश्चन का लैंग्वेज रीड करोगे तो आपको मैच करने में प्रॉब्लम नहीं आनी चाहिए। ठीक है, वो एक बहुत सिंपल 1-to-1 मैपिंग है जहां पर यू शुड बी एबल टू क्लियरली सी कौन से कंपाउंड का नाम क्या है। So you get the moles of potassium benzoate, you get the mass based on the molecular weight, and then you are given द यील्ड। ठीक है, तो ये जो अपन ने कैलकुलेशन करी एक्सपेक्टेड कैलकुलेशन थी, एक्चुअल कैलकुलेशन तो यील्ड से आएगा। सो जितना आपने एक्सपेक्टेड निकाला उसको आपने यील्ड से मल्टीप्लाई करा, तो इक्वेशन बना जिससे आप एक्स का वैल्यू कैलकुलेट कर सकते हो एंड अपना आंसर ला सकते हो। ठीक है, 22nd question, again not too good in calculations, definitely there are many possible approach to answer this question। I have adopted this one because मेरे को moles में calculation करना ज़्यादा आसान लगा as compared to mass में। mass में करता तो फिर denominator में I have to put molecular weight and थोड़ा सा थोड़ा सा ट्रिकी हो जाता, मतलब थोड़ा और कैलकुलेशन गंदा हो जाता है। यहाँ पर एटलीस्ट मैंने मोल्स मान लिए स्टार्ट में, आप मास से भी कर सकते हो, थोड़ा कैलकुलेशन ज़्यादा हो जाएगा बट आंसर डेफिनेटली सेम आएगा। सो आपने यहाँ पर मोल्स माने CuSO4.5H2O के A, तो उसका मास कितना होगा उसके मॉलिक्यूलर वेट से मल्टीप्लाई कर दिया। सिमिलरली MgSO4 का आपने मोल्स मान लिया भी, उसके मॉलिक्यूलर वेट से मल्टीप्लाई कर दिया, तो दोनों का मास ऐड करा, वो 5 ग्राम होना चाहिए, पहली इक्वेशन है। अब आप यहाँ पे नोटिस करो, अगर आपने इस पूरे कंपाउंड के मोल्स A माने हैं तो इसमें जो CuSO4 है उसके भी मोल्स A ही होंगे, क्योंकि इस पूरे यूनिट में एक यूनिट के अंदर एक CuSO4 होता है, तो ये CuSO4 के मोल्स हो गए इनटू उसका मॉलिक्यूलर वेट। ठीक है, वाटर हटा दिया यहाँ पर क्योंकि अभी इवेपोरेशन हो गया था। सिमिलरली अगर MgSO4.7H2O के मोल्स भी हैं तो उसमें जो MgSO4 वाला पार्ट है उसके भी मोल्स भी हैं और उसके मॉलिक्यूलर वेट से मल्टीप्लाई करोगे तो ये रेसिड्यू का मास आपको मिल जाएगा विच इज 3। तो दो इक्वेशन दो वेरिएबल है। ठीक है, बोलने के लिए अच्छा है दो इक्वेशन दो वेरिएबल, बट सॉल्व करने में मुझे भी टाइम लगा। It is not something I have not shown the calculation here, I did not want to waste the effort here, ये मैंने अलग से कर लिया and directly यहाँ पे आंसर लिख दिया, but it took some time and not a good piece of calculation। ऑलराइट 23rd में अगेन बैलेंस्ड इक्वेशन आपके सामने है एंड दिस टाइम द क्वेश्चन इज स्ट्रेट फॉरवर्ड. मास दिया हुआ है, मोल्स निकाला आपने, उससे लिमिटिंग रिएजेंट आइडेंटिफाई करा एंड देन लिमिटिंग रिएजेंट के बेसिस पे यू डिड द मोल एनालिसिस. इससे आपको मोल्स आ जाएंगे एस्पिरिन के, उसका आपने मास निकाल लिया एंड बेस्ड ऑन दैट देन यू कैन कंप्यूट द परसेंटेज यील्ड. इट इज नॉट समथिंग व्हिच इज troublesome, easy to do and get. 24th question is straightforward again, similar to the previous question only. मास दिया हुआ है तो आपने उनके मोल्स निकाल लिए in terms of their molecular weight. Okay, this is something which I wanted to also highlight as an important point because some students tend to do this thing. वो क्या करेंगे यहाँ पर नोटिस करना, ये 2 मल्टीप्लाइड है xi3 के साथ में, तो उसका मॉलिक्यूलर वेट लिख देंगे 2 टाइम्स ऑफ दिस. ठीक है, 2 टाइम्स ऑफ x प्लस 3 इंटू 127. ये गड़बड़ है बाबा, ये नहीं करना है. ये जो मॉलिक्यूलर वेट होता है किसी भी कंपाउंड का, ये उसकी इनहेरेंट प्रॉपर्टी होती है. वो रिएक्शन में, किसी एक रिएक्शन में हो, दूसरे रिएक्शन में, तीसरे रिएक्शन में हो, रिएक्टेंट साइड पे, प्रोडक्ट साइड पे, उससे थोड़ा फर्क पड़ता है. ये तो इनहेरेंट प्रॉपर्टी है. इस रिएक्शन में इसका कोफिशिएंट 2 है, किसी और रिएक्शन में इसका कोफिशिएंट 4 5 कुछ भी हो जाएगा, उससे मॉलिक्यूलर वेट थोड़ा चेंज होगा. ठीक है, सो यहाँ पर my mass was 0.5 grams, तो मोल्स हो जाएगा mass divided by molecular mass, and molecular mass is just of the formula, the compound that you have in front of you. ठीक है, तो यहाँ पर भी आप नोटिस करना, प्रोडक्ट साइड में ही वैसा करा है. ठीक है, तो एंड देन उनके बीच में यूनिटरी मेथड लगा के मोल एनालिसिस का मैंने x का वैल्यू कंप्यूट कर लिया. ठीक है, so I think these were the questions and this was something which I said in the beginning itself. Calculation थोड़ा गंदा था, but again I am repeating that it will not be the case when you are going to give tests. ठीक है, all right, so thanks for your patience guys. I'll share this as well as I'll share an assignment with you also. Thank you.